CX Alloy is leading the way in revolutionizing the commissioning industry.
I came with a mission and a vision for CX Alloy. And that mission is to aid commissioning firms in capturing and amplifying the full value of their efforts.
When we talk about commissioning and CX Alloy and softwares like this, is not adding extra work, but just making it easier for everyone. That's where CX Alloy really leverages a lot of the things within the commissioning process and makes it easier for people to use.
CX Alloy is super useful for having all the information at hand and being able to give that information easily and aesthetically.
CX Alloy is not about adding extra work, but alleviating it.
Good afternoon. I'm William Thomas with the Energy Management Association. I'd like to welcome you to today's webinar and thank CX Alloy for sponsoring today's session. A few items before we get started. This presentation is being recorded and will be available for viewing in 1 week. The presenter will be holding questions until the end of the presentation, but we encourage you to submit them at any time using the Q&A button at the bottom of your screen. If you happen to be experiencing technical problems during the webinar, please use the Q&A button to let us know and we will assist you. In terms of continuing education credit, everyone in attendance for the full webinar will receive a certificate of attendance sent to their email within 24 hours. And finally, if you are a certified CXA or EMP, your CEUs will be automatically uploaded to your respective portals within about a week. Today's webinar is Getting Connected, BAS Cybersecurity, Network Architecture, and Connected Commissioning, presented by Derek McGarry from OTTO. Derek McGarry is a mechanical engineer with 25 plus years in the built environment, currently focused on connected commissioning and automated functional testing. He's a Cornell graduate and has served on a local ASHRAE and USGBC boards. I'll now hand it over to Derek to kick things off. Derek?
All right. Thanks, William. Great introduction. To get things started off, and I think I'll segue this presentation by making a couple comments also about CX Energy last week. Wonderful conference. I know you were there as well, William, working hard. The topic we're talking about today is largely around connected commissioning and automated functional testing, and it was great to see the energy around that at the conference last week. Our friends at Lawrence Berkeley National Labs and Armando Casillas did a great presentation on automated functional testing. We had our friends from Salas O'Brien, or the Impact CX affiliates, talked about connected commissioning and automated testing. Ping CX did a wonderful presentation on automated testing. I'm going to throw out some competitors' names here as well. You had Ace IoT as a vendor. Sky Foundry was there, big analytics engine. Clockworks and Coppertree, I saw them. CIM, SIM, EEI, they have an analytics type automated commissioning thing. They were exhibiting there as well. Group 14. There's a lot of energy going on around this in our industry right now. Specialized and McKinstry, both big users of automated testing and connected commissioning, and even from a controls contractor, so ATS automation there. So a lot of good stuff, a lot of folks in the industry we can lean on to deal with this topic. Real quickly about OTTO. OTTO, we are a service provider to commissioning providers. So we do not do direct commissioning. We provide technology to make it easy for commissioning providers to do connected commissioning, what we're going to talk about today. We do have a relation with CX Alloy. CX Alloy acquired us last summer, and some exciting things are coming up in there. So enough about the commercial. Let me get into the presentation here. So cybersecurity and networking is intimidating. There's no ifs, ands, or buts about it. It's intimidating. Most of us here on this in this presentation, we are mechanical folks, maybe electrical, commissioning providers, commissioning and energy experts. Cybersecurity and networking is a specialty that some in our industry choose to focus on, but broadly speaking, if you are a commissioning provider, you are not expected to be a cybersecurity expert, but we do need to understand some basics. We're all part of the cybersecurity protection for anyone in our own companies, for that matter. But beyond cybersecurity and networking being intimidating, connected commissioning is powerful. Once you get your hands on this, you are not going to want to do another project without it. And just to be clear, as William introduced me, I am a mechanical engineer. I am not a cybersecurity expert. I'm not a network engineer. I'm not a controls contractor. I'm a mechanical engineer who loves high performance buildings. And it was about 15 years ago, I got my first taste of automated fault detection, passive fault detection, which is fairly mature now in the industry. And so I've had 15 years of getting connected to buildings, and that's what we're going to talk about today. So here are some learning objectives that were posted. I won't read through these, but I'll just leave it up here for a second, just so you can kind of make sure you got your frame of reference of what we're expecting to cover. So some things to think about. This is not an interactive presentation, so these are, I guess, what do you call them? Hypothetical questions, rhetorical questions. What percentage of your projects have controls on them? I mean, that's just a reality. If you don't have a control system, we're not really talking about connected commissioning. So just to be clear, connected commissioning is fundamentally about getting you connected as a service provider to the value of what's inside that control system. So when you think about what you've got that in terms of your normal day-to-day work, that's how you can put this into context of how it impacts your business. Now, when we're talking about control systems, just to be clear, we're talking about new construction and existing buildings. So most people, when we talk about fault detection or analytics, their head immediately goes to operations and monitoring-based commissioning. And boy, wouldn't I love to do MBCX. And but the reality is, our industry, commissioning providers, 95+% of our revenues are coming from new construction projects. So that's where really the power of connected commissioning comes into play. So when you think about how much time you spend on functional performance testing, that also speaks to the relevance of this topic to your business and to your practice. Just to get a frame of reference of how much certain things cost, you have a particular project with air handlers, a central plant perhaps, but then lots of terminal units. Terminal units are high volume, and it can eat up a lot of time. I normally hear that commissioning providers are budgeting roughly 30 minutes per zone for functional performance testing of zone type equipment. So what does this look like when you're testing this zone level stuff? That's mostly what we're going to what we think about when we talk about automated testing. But what you're really doing is you're looking at a computer. The controls contractor must hook up to the control system to execute the procedure that you want them to execute, the one that you want to witness. And normally witnessing means looking at the graphics or some data points in live values on the control contractor's computer screen. That means that you are in close quarters, by the way, looking over their shoulder, perhaps in a mechanical room, dusty space. It speaks to kind of the situation of what high volume repetitive zone level equipment testing, what it's like. So trend data. We all want trend data, and we are supposed to get trend data as part of the specifications normally. But the reality is, getting your hands on trend data before the end of construction, before turnover, before you've done functional testing, or even while you're doing functional testing, is a rarity. It just we want it. And why do we want it? Because it's really powerful and helpful to understanding how systems operate, but we rarely get it. So what if you could get secure remote access to the control system early, around the time of test and balance? What if you had independent of the controls contractor, trend data on all of the equipment that you care about that's in the control system. So all the HVAC for the most part. And then, of course, the real game changer in the industry going on right now is automated functional testing. And there's a lot of different ways to accomplish this. So I come from my experience in it, but we always have to appreciate that there's a lot of different ways of doing things. Just like you ask 10 engineers how to, write a functional test procedure for a VAV box, you might get 10 different answers. So yes, we would love to have, I assume that's what everybody's saying, we would love to have early access, trend data on everything, and shoot, automated functional testing, give it to me. So let's talk about modern commissioning. So we got some realities here, is that a computer is mandatory to interact with HVAC in a modern building. It's again, I'm assuming we're talking about projects with control systems. So the idea of getting connected is not a strange idea, even though some people gives them anxiety. So what does a HVAC control system look like? In its most basic form, there are master controllers and then lots of application controllers application-specific controllers or equipment controllers downstream from it. So in this little diagram right here, most control systems you see these days is this top version where you've got a master controller like a Jace or a Johnson Controls, calls them SNEs these days. Could be a BACnet router from Delta or Reliable, and then downstream from this BACnet router or master controller is going to be a bunch of HVAC devices, typically MSTP. So for most computers, your technician is going to be hooking up to the master controller to see everything downstream. You do see in the last few years a lot more of 100% IP control systems. And what I mean by that is these gray objects are IP objects on this diagram. The blue ones are MSTP. That's old school and it's current school. MSTP is super popular. Serial communications. You daisy chain these, VAV boxes or fans or fan coil units, whatever. Daisy chain the controllers together, and they all talk in that line. So naturally, if you convert those and instead use IP controllers, we're talking about Ethernet cable. We're talking about orders of magnitude more communication capacity. But either of these scenarios can handle analytics and the types of things that we're asking a control system to do that we're talking about in this discussion today. So, and one more thing I'll note about this is every device has an address. So I don't necessarily need to see this architecture. I could get a list of 100 devices and their addresses, and I could quite intelligently draw this architecture based on that addressing. That's the importance of the addressing, has important information in it. And we'll need to know this addressing to do connected commissioning. But I'll just go ahead and say it. If you've never noticed, every single device has an address. So getting that information is not a hard thing. Now, back to the realities. One of my goals here is to demystify the idea of connected commissioning. That is not that big of a deal. It's not scary. And this is a case in point. Again, anytime you're doing functional testing in a modern building that has a control system, you will be connecting to it. You just happen to be standing right there. It's probably the controls contractor that's doing the connecting. And again, you're looking over their shoulders. So when we talk about the opportunity with connected commissioning, it's this similar type of thing. It's essentially the same thing, but there are a key difference here. Is we're bringing that connection remote. And we're going to talk about how to make that happen. But the main thing is that you have some sort of communication gateway, some sort of communication out to the internet. Now, I'm going to say one thing that is pretty important right here. I've done these presentations quite a lot, and I do try to be non-commercial in who, or how. We'll just try to be non-commercial. What that means is when you're talking about something that's specialty, is it can leave the audience kind of confused or unknown of how to go about doing this. And so I want to say it's a very important point. There are do-it-yourself ways of going about this, but there's no way around software. You must have software that can speak BACnet, speak to these control systems. You must have some sort of networking gateway technology and familiarity with it, or you use vendors. And there are lots of vendors. I named a bunch at the start of the conversation. There's vendors that come to these conferences. Those are the folks to ask for help. Controls vendors is a good place to start too. So, and of course us. But there are quite a few folks that can get you down the path to start chipping away with this challenge, how to tackle this challenge. But the first thing is, oh wait, sorry, before I move on to this next part. Yeah, getting remote access is fantastic. If you're sitting in this guy's seat right now in the picture on the left, you right now, without any special software, just with this gateway, could access the login for the Jace or the login for the JCI Metasys system or the whatever brand of system it is. And normally you don't get access to that during construction. And by the way, even if trends and graphics haven't been set up yet, there's a lot of value to gaining access to that login. Just to see how they've got devices structured in their tree, the controls contractor that is, what devices are missing, which ones are in fault. You can start exploring points more in table format. But that's a big value right there, just getting connected. And you'll see, by the way, a lot of controls contractors these days are doing exactly this, putting in some sort of cellular device to get connected remotely so that they can do work more efficiently and have their eyes on the project whenever a question comes up. But what if you can take that a lot further, get trend data and automate functional testing? Now, there was a presentation and discussion at a couple of presentations actually at CX Energy that talked about automating functional testing on a wide variety of things, which could include, complex air handlers, central plants, and all sorts of zone level type equipment. My experience it does apply to all of those systems. We've tested variable primary chill water systems. It was like a 10-hour test procedure. We tested complex air handlers and all sorts of zone stuff. At this stage, it really feels like that, without a doubt, the biggest bang for the buck for getting involved in connected commissioning on your projects is to automate repetitive stuff. And there's multiple reasons for that. One is you create a test script for a VAV box, and if you got 100 of them, you're going to apply that times 100. You only have to make that test script. With automated testing, you can run it as many times as you want. You can be guaranteed that it's going to be the exact same procedure every time. But better than anything else is you're taking the most tedious, time-consuming, and error-prone scope of work and automating a good chunk of that. Then you get to deal with the fun part, which is to absorb the results and determine what's important for your owner's needs. Okay, getting connected. That's the quite honestly the hardest part. And I have a couple of different devices shown here on the screen. The main concept is during new construction, you normally don't have internet. The owner is not connected to the control system yet. And so to have a solution to get connected with your own internet source is golden, and it gives you access to all your projects, essentially. Kaiser Permanente, a big owner, they spend millions of dollars a year on commissioning services. They have a requirement, mandate for all their commissioning providers to utilize connected commissioning, and they say if the owner's network, Kaiser Permanente's network, isn't up by the time you have to do functional testing, then use what they call Plan B. This is Plan B. Bring your own cellular to the table. Now, network is not going to be ready. So you must have your plan B. Plan B ends up being a plan A on new construction. It's just the way it is. The key thing here, from a cybersecurity perspective, is outbound only. So I get this question all the time. Just had a client call me today asking about it about an hour ago. If we do outbound only, how the heck are you doing overrides? And so I always think it's important to clarify this is terminology matters, and it matters to who we're speaking to. To us mechanical folks, outbound only is a direction, and it means only outbound, or to anybody with logic, doesn't have to take that back. To IT folks, that means something very specific. It means that communication is initiated from inside the network. That means that they are giving permission. If they have a port open to the outside that enables inbound connection, then they have a lot higher risk. So outbound only means the communication is initiated from inside the network. That reduces risk substantially. It's a measured risk that they know what they're taking. Again, remind you, you don't have to be the cybersecurity expert. You have to provide the information and ask the right questions to let your owner's IT and networking experts understand what you're asking to do and bless it. And again, keep in mind, in the context of new construction, more often than not, the owner is not connected. There is no internet. So you're dealing with what they call an islanded network. And you're getting hooked up to an islanded network that's of systems that are under construction. The owner's cybersecurity concerns are going to be a lot lower at that stage in the game. And it will change later. So it's good to have flexibility. But here are just some bullets around cybersecurity. But the main thing I think is that seems to resonate the most when I'm having conversations with IT folks is we want to use a communication method, a gateway that is outbound only and establishes a secure encrypted VPN tunnel to our software. Once we have that tunnel established, we can do bidirectional communication, no problem. And it still satisfies the IT definition of outbound only, just to be clear on that. And that's a big deal. Okay, I've got a couple example architectures here. So because I have a few, I think it's okay to show logos. I mean, we're in the industry. It's educational in my mind to understand products that are out there because there are differences between them. Knowing those differences is also very valuable as a practitioner, I've found. So in this example here, we have a typical Schneider architecture. They are unusual, and they almost always, I haven't seen a non 100% IP system from, well, I take that back. Schneider routinely uses all IP controllers, meaning they're not MSTP, they're actual controllers that you plug an Ethernet cable into. You can daisy chain those together too. And actually in this, and that's what these yellow devices are, this is all BACnet IP communication. You do see a handful of devices down here on the lower left. Those are look like those are probably packaged rooftop units that come with factory controls with this and those are BACnet MSTP. They don't come as BACnet IP, so they're integrating those. But all of these devices talk to this master controller, this ASP up here in the top left. That's where you connect. If you have software on your laptop and you're in the field, you plug your laptop in to one of these two ports, and you're likely going to be able to access this stuff. Simplifying it a little bit, you need to know some network information, but these are simple questions that the controls contractor will know. But the main thing I want you to take away here is that when we go through these diagrams, there's a place to plug in. There's a place a computer can plug in, and then everything else looks kind of noisy, but those are all the devices that will each have an address. So it's really just a list of addresses for all this stuff over here to the right. Another note here, you see there are two Ethernet ports on this particular device. Not all controls brands have this, but many do, where it's essentially a primary network connection and a secondary network connection. That means that this blue line, it says, might be hard to read, it says customer network. That has a different configuration than the yellow side, which is, I call it the secondary side. And in this case, because those are all IP controllers, you got this switch down here. you could plug into that switch and see everything on the control system. Or you could plug in on the blue side and see everything in the control system. And either way, it has some subtleties in terms of what it means to cybersecurity. But there are, I guess, one of the takeaways here is there's optionality that I didn't appreciate until the last few years in terms of how to, someone says, "Oh, I don't want you doing that." Well, why don't we do this? So there are options. Okay, next example here, carrier iView, very similar to, I think it's the same as automated logic, a little bit different branding. They basically have these XT routers. That's their master controller. So you see the owner's side is in this network switch up top I'm hovering near. That's where you can plug in. Or you can plug in directly to the XT router, and then you'll see everything downstream. Everything downstream is the stuff off to the right. See air-cooled chillers, outdoor air handlers, VAV boxes, air handlers. All those things in this case are MSTP devices, BACnet MSTP devices. And we can see those if we plug into the XT router. All right, reliable controls, another example. They have this BACnet router called a Mach Pro, MPC, I think some people refer to them as. So over here on the left in this diagram, connect there, and you can see everything, all those other stuff downstream of it over to the right here. That's from a control submittal using reliable. Another example, Johnson Controls, the Metasys. The old engines were called NAEs, the new ones are called SNEs. There's a variety of other ones as well. I'm simplifying, but these are where you get connected. And some of these also have both a primary and secondary port. You see, in this case, there are, looks like two Ethernet trunks, the blue trunks. So those are all devices, BACnet MSTP devices on the right. And you see a connection to the owner's switch over on the left. That's just effectively where you would have the opportunity to get connected. Now, by the way, even if an owner does have their network connected, we've done plenty of examples where you just disconnect them from the control system for the purposes of your visibility and testing on a temporary basis, and then move on. As an example, we got hooked up at Denver Airport last Monday morning. And we got removed this Monday morning, and all testing was done. A week's worth of trend data on air handlers and terminal units, and ran automated testing on all the terminal units. So temporary connections can go a long ways to getting your work done. So that also reduces cybersecurity concerns if the owner is not connected. Again, you want to have that optionality. You want to have a cellular plan B solution, as Kaiser Permanente calls it. Another architecture here, KMC. They use these KMC branded BACnet routers. Same thing. You can connect to those routers with an Ethernet cable to your computer or to a gateway device, and apply it to software and be able to speak BACnet to everything downstream from there, which is over on the right. Allerton, one more example here. What is called ACM. You see they have an Ethernet 0 and Ethernet 1. That's another one of these primary and secondary networks. This one came from a pretty large project, and you'll see what's fascinating here is you actually have a contractor's network or service network and an owner's network in parallel being built out. And I've seen this a couple times. I'm not 100% on why, but I believe it's because the controls contractors get just as amount of value as having visibility and connectivity as you would as a commissioning practitioner or a witness to what's going on. So it's going to be super helpful for controls contractors to have that secondary access and not have to concern the owner as much with cybersecurity questions. Honeywell, similar structure. You have your front end devices, the master controllers. In this case, those are JACEs. JACEs, if you didn't know, are sold under lots of different brands. And this is a pretty complicated diagram here, but all you need to really know is hook up to one or three of these front end devices, and you'll see everything to the right. So that's what that looks like. Okay, so now we have early access. Again, I'll remind you that I can make it sound easy, and it is, I guess, fairly easy from my perspective, but you know, networking is a specialty. Software is software development is a specialty, and mechanical is a specialty. Controls is a specialty. So to know all those specialties is kind of tricky. You need a team. So reach out to some vendors that you think might be able to help you down this path and get started. You'll love it, I promise. Okay, so once you're connected, what are some things we can do? So pretty common thing is discover. You can discover all the addresses for those BACnet devices. I kept on mentioning that it's just a table of devices. They all have an address. And for, well, I don't really need to get in the details of what all's in the address, but there are lots of free software tools you can download online to discover BACnet devices on a network. So if you put that software on your laptop and you plug it into one of these front-end devices that I just showed you on all sorts of different brands, you can discover all the devices that are discoverable. And worth noting, if a device isn't there, then you don't know whether it was there to be discovered or not. So it's also, if it's new construction, you'll want to cross-reference with the controls submittal to what you're expecting to see. And new construction, a controls contractor can easily get you a list of all these addresses as well. Also in new construction, you're normally going to see a list of these addresses in the controls submittal, but also normal to construction, it is not going to be accurate until as-builts are submitted after the project. So a go-to resource is always to ask your controls contractor to get you a list of the devices addresses so you can know what you're expecting to discover. Once you make a connection to BACnet devices with your software, whatever that is, then you should be able to view points lists. And I know that's also available in free tools. So for a typical VAV box or fan-powered box, these days, if you downloaded a points list for it, you're going to see roughly 80 points. And what do you normally see on the graphics? Maybe 5 to 10 points. But what would you really like to see? Maybe 15 to 20 points. So when you see all these points, you got to pick what it is you care about. And this particular example here, over here on the right, far right side, has acronyms to what those points are. And some of the points have a description with a few words to help you tell what they are. Normally, when you discover the points, you can also see what units they're using. That can clue you in onto what the data is you're looking at. Interestingly, and I guess not surprisingly, you'll see the same acronyms used from on the East Coast to the West Coast in any given particular brand. So this is, I think, a JCI example here. It's almost always DA-T for discharge temperature. And you see over here on the left, we call them our own acronyms, SA temp. So you can rename points in your software to what you want to see. But this just gives you a little taste of what it looks like when you download the points list. You'll see the stuff mostly over here to the right, and that's what you'll be picking from. So now we got points, so we're going to start collecting data. I'm not sure there's any free software out there that can collect data. There probably is. I don't have experience with it, to be honest. I've heard of something called Voltron. I'm not sure if that's helpful or not. I know that's open source, so I feel comfortable saying that in terms of non-commercial. But we use a paid software, which we should resell effectively. And so that's how we go about doing that. So you'll need some sort of software to do this. But once you have access to the controllers, the controller addresses, then you'll have access to all the points. You pick the points you want, and you start collecting trend data on those. And now you've got visibility. You could stop here, and connected commissioning would be awesome. Just to have visibility. Think about how many times you've gone on site to discover that you have to reschedule for the next week because of something that if you had had visibility of the control system, you would have known before you bothered making that 2-hour drive to the site. That alone can start paying for all this type of stuff. So visibility is awesome. And I probably am preaching to the choir on that point. But it amazes me, we haven't had connected commissioning. Is not very common for new construction. And so we've, as an industry, we've had to deal with accepting, 10 to 20% sampling on terminal units, not getting trend data on stuff to look at in a timely manner, before turnover. We want that stuff, but we just can't get it done. So now it can be done. Okay, let's talk about automated functional testing here. I think I'm going on time here. I'm going to try to finish up at 2:45 is the idea. 10 more minutes, allow some time for some questions. But when we talk about automated functional testing, it's fair with any terminology in our industry that folks will use it differently. Okay, so let me just say, when I talk about automated functional testing, what do I mean? I mean, really, when you think about sending someone to the field to test 100 terminal units, first, you're going to create a procedure, right? And then you're going to ask, you're going to go on site normally, and you're going to connect with the controls contractor, normally just one technician. They're going to pull out their laptop, they're plugged into the control system, and they are supposed to execute your procedure. So you're asking a controls contractor, a person, by the way, to execute a procedure 100 times so that you can witness it. Now, is that really happening one by one? I highly doubt it. Only you know what happens when you go out in the field and do your terminal unit testing. But the reality is there's a lot of room for error. There's a lot of tedious aspects to it. And but the main point I'm making here is that you're asking for a procedure to happen. So if you automate it, like, what's the difference? In terms of the fear factor. We're not doing anything special. We're just automating what you told the contractor to do. Now the contractor, by the way, doesn't have to do this on 100 boxes for 50 hours worth of labor on site to walk you through and demonstrate the testing. Now, don't get me wrong, witness testing in physical is important. It is not the same as witness testing remotely. With that being said, when you're witness testing terminal units, you're witnessing it on a computer for the most part. But you can use this tool however you want. But the reason I'm kind of talking about this is a lot of times when people hear automated testing, they start closing up and backing away because it's uncomfortable, the idea of not being there. Be there all you want. Take the power of this information and show up on site and be the smartest one there. That's what I do for. Okay, automated testing. You got the override piece. That's just automating the override. So you want to force a system into cooling mode, into heating mode, into neutral, unoccupied, same thing. Maybe you want to test a CO2 sequence. So you can script that. Someone can code it for you or whatever, use software to make it happen. And it'll happen every single time. If you're scripting it, why not make it a little bit longer than you normally would? You see that you put it into heating mode, you want to see the valves start to open, the discharge temperatures start to get warmer. Why not wait, 20, 30 minutes and let it settle and let it, settle at its target 85-degree discharge temp and ASHRAE 36 heating mode, whatever. Let it settle on its airflow. We don't normally spend the time to look at this stuff, but when you automate it, you have the luxury, you don't have to, but you have the luxury of making it a 4-hour test, a 7-hour test if you want. Run it at night, run it on the weekends. Then on the right side, here you see the second part of an automated functional test, which is to automate the results. So normally you're telling the contractor to do all these procedures for you, and you're witnessing it, and you're capturing the information, hopefully in software, not on paper, but have at it whatever way you want. In this case, we're doing it for you, or somebody's software is doing it for you and answering all these questions. A person is an expert does not leave the equation here. An expert now has the results to focus their high dollar, high value intellect onto the things that matter most to your owner client. So that's the power there. Okay, a couple little examples here. This is from a retro commissioning investigation. You got 100 boxes that you ran automated testing on, scheduled in consultation with the owner between the hours of 8 p.m. and 4 a.m. on a Monday, Tuesday, Wednesday, and Thursday. You didn't step foot on site. You actually set the gateway to the owner's, BAS in-house expert, whatever, that plugged it in, got permissions from IT and everything. Now you run all this testing. You haven't set foot in the building yet. It's retro commissioning investigation. Now see what you're armed with. You got the results here. Excuse me. So I zero in on one functional question. We're in occupied cooling mode. So you see some lines of functional questions below it. Just reheat valve at 0, commanded to 0. All 101 boxes, sorry, I said 100, are commanded to 0 in this case. But only 71 of them actually have cold air coming out in a high cooling situation. And we're defining that as 5 degrees above the inlet temperature coming off the parent air handler, as you have that data live. So if you look over on the right here, there's the results for all 100 boxes in a nice table, and you can quickly sort, and you can see that that this top ones are fairly juicy opportunities where you got a valve commanded, reheat valve commanded to 0%. You got cold, mid 50s air coming into the box, and you've got 70 or warmer air coming out. And some boxes up in the 80s, a couple up here at 108. That's a fantastic, juicy retro commissioning find right there. That's most likely, a good chunk of those, not all of them, are hot water getting through a valve. They're not actually closed. So good retro commissioning example there. Right here at your fingertips. Now you go to the field and you focus on these zones. And then another example here, go to heating mode. You expect all the reheat valves to be open, and you expect the temperature to be, warm. You define that however you want. In this case, we're just highlighting it by, was it over 80 degrees? Then you can look at the results over here on the right. You see about a dozen boxes apparently have bad sensors, minus 98 degrees. Okay, great. I didn't have to look those individually over someone's shoulder to see that. It's right here, the results are for me. In this case, we also have hot water valves stuck closed. So you have ones that are commanded open, and you've got cold air coming out of the box or being sensed out of the box. Of course, calibration could be an issue, bad sensors also, but this is juicy finding. So this is more comfort related, where you're just not getting enough warmth to the space. Now, with automated functional testing and connected commissioning, you are collecting trend data the whole time. You're not writing down what happened after you put it in the heating mode, and it's just one, a couple data points, point in time. You've got interval data collected the whole time. For that matter, you are on site doing central plant testing, air handler testing, hood sash testing, all sorts of different stuff. You are collecting data this whole time. That is big value. And you have that detail to back you up. You don't have to look at it, but it's there. So that's it. We're at 2:43 here. And so I'm leaving some time for some questions. And yeah. So William, I was going to let you facilitate that.
Insight. Thank you so much, Derek, for that insight. That was a great presentation. We do have a few questions that are already in the chat, and like I put in the chat as well, please, if you have a question that you would like to ask Derek, please feel free to submit them into the Q&A. So let's get things started. We have a first question is from Andre. Their question is it BACnet SC? Once again, their question that they're asking is it BACnet SC?
Sure. Yeah. So he's referring to BACnet SC. So BACnet SC, I referenced BACnet a good number of times. We wouldn't be able to do, connected commissioning wouldn't be so accessible to the commissioning community if it wasn't for BACnet. It's an open standard, open protocol, if you will. BACnet SC is an evolution of BACnet. I believe SC stands for Secure Connect. It's still a discussion item. I have yet to see it deployed. The intent of SC is that you will not be able to interact with or access a BACnet network without credentials. Sounds pretty basic. Well, that's why they're coming up with BACnet SC, because right now BACnet is normally well, does not require credentials to access it if you're on the right network. So there's ways to protect it, but BACnet SC is a whole deeper layer. We have not encountered BACnet SC yet to answer that question directly. All right. Anything else, William?
Yeah. Our next question is from Julia. The question is, what steps do you take to confirm the equipment in the field is responding correctly? As a CXA, I'm frequently troubleshooting in the field with the contractors during testing.
Okay, yeah. Ask that first part again. I think I caught it all. Just want to hear that first part again.
Oh, yes, of course. It's what steps do you take to confirm the equipment in the field is responding correctly? As a CXA, I'm frequently troubleshooting in the field with the contractors during testing.
Okay. All right. I think I got it now. Okay. That's a very, very valid reality here, is that just because you got 100 boxes to test, you know, I made it sound like all you're going to do is sit there in the mechanical room and test them and fill out 100 forms and then walk away. You know, you're doing high value, you know, hands-on, interactive functional testing in that example, Julia, where it naturally feels a lot more efficient. If you run into an issue when you're testing box one, let's go ahead and fix it. If it's a controls issue, as an example, or you're questioning a sensor output, well, let's go take a look at it. Very valid point. So how you fit a tool like connected commissioning into your workflow is up to you. And there's a lot of flexibility on how to do that. Some of our clients like it because they bid a project to do 20% sampling on all the terminal units. All their competitors are bidding or whatever, providing a fee based on 20% sampling. Now they can come in and do 100% sampling for roughly the same cost. So, you know, they're juggling things to make calling that a high value thing. I've got other clients that routinely do healthcare, hospitals, or biotech type stuff, where 100% testing is a given, that they will be doing 100% testing. But to have all this data before they go to the field, they're armed with that to be more productive in the field. And then another thing that I'll touch on is just the realities of how people define functional testing versus pre-functional testing versus IO verification versus startup checklist. You know, there's a number of things that are supposed to be done before you get to functional testing. So, you know, theoretically, when you do the functional testing, those issues are not supposed to be there. But when you're doing automated commissioning, now you do have the option of doing it early. And bad sensors or miscalibrated stuff will show up. Won't catch everything, but you'll be amazed by what shows up. So I'll stop there on answering that. But very good question. Very good point.
Our next question. Yep. Our next question. Julia, she went into deeper to clarify my question. What about if a damper shows open on the control system, but isn't actually open?
Yeah, well, there you go. So triangulation with data, it goes a long ways. I'm sure I can come up with examples where we cannot triangulate to come up with the answer. But I mean, if you got, you know, typical, let's see, I think I had a example here. Yeah, so I mean, just in this graphic I got pulled up right now, you've got, I'm not showing the damper position. I don't see it on, yeah, I do see it on the right. Looks like, let's see, 345, 345. Yep, I've got the thing over here on the right. It looks like the damper is about 70% open. You got the reheat valve 0. You got airflow set point at 1920. Your airflow reading is at 1920. And so the triangulation of that data suggests that that damper is open. If you'd had, you know, deficient airflow or no airflow while the damper was reading 100%, well, there's your triangulation that says that that damper's not actually open. So it's quite amazing how triangulation of the data can catch these things. It's all heat balance. You need all 4 or 5 of those things in that equation to match up, and if they don't, that's an issue, and data can catch that. All right, I'll stop there on that one. William, anything else?
Yep. We have our next question from Dominic. The question is, would the network architecture be similar if one is looking to install a more permanent solution through an EMIS or FDD tool?
Yeah, so great question. And this is actually a really big deal. The bulk of the industry experience and exposure to analytics software, which is a broad category to describe what we're using here, is in operations, ongoing operations. And the mentality of that is that you have some time to set it up, and that it's for the ages, for multiple years. And so you're looking for a what would you call it, like an enterprise type of installation solution. And you might do something a little bit differently than what you would do during a short-term construction project. So yeah, how you get connected can change between what a new construction phase type stuff would look like versus long-term. If I look at as an example over here, let's see, I'll pull one up here. I've got a high school project going on right now with lots of these BACnet routers. They're going to be finishing it up in phases. So we're doing one router at a time. Hook us up, then collect the trend data. We collect the trend data, run the testing, move us on to the next one. The reason we do that is because the routers themselves are not going to be networked together upstream until later on in the project. That's more along the lines of the owner's scope to do that. So in this case, it behooves us, or whatever, if you have testing to do, we can't wait for the owner to get their stuff done. We can't wait for an enterprise connectivity solution. So being fast and getting connected at the time of test and balance is likely going to look different than an enterprise connection that you work to get approved and go through all this process and get it connected, 3 to 6 months after project turnover. It's a different mindset, but I will say utilizing cellular and coming to the table with a solid cybersecurity approach. We have ongoing multi-year projects with multiple gateways on them, where we've where's an example here? Got an example. These 3 JASES here in a hospital, 1, 2, and 3 floor. During construction, they weren't networked together. We connected 3 different cellular-enabled routers to them. The cost part of that is really not a big deal when you're talking about what the purpose is. So we leave those in place. We're on the secondary side of this network. I mentioned primary versus secondary. The owner ultimately connected the primary side, and that's what they access, but we're still connected using cellular on the secondary side. So there's just lots of different ways to do the connectivity approach, and that's a great question. But there's getting connected during construction looks usually a lot different than an enterprise long-term connection. All right, I'll stop there on that one. Mm-hmm. Any others, William?
Yep. So our next one is from Joseph. His question is, can you touch on the purpose of an additional device to secure a network? For example, a firewall device attached to the master control /JACE, JACE.
Sure. So I can lightly touch on that, but the way I'm going to answer this is to go back to the to this one of these first comments I made about cybersecurity and networking. I've been getting connected to buildings for 15 years for the purposes of connected commissioning. I'm not a cyber expert. Understanding what's in place is what enables where is the proper way to get connected, and what are the options here. If I understand, Joseph, your question, maybe you're talking about I think I saw a blog. if you're the same Joseph I'm thinking of, posted by you about network transport layer, a third layer up to help segment things. Sure. I come at it as a cybersecurity networking expert is responsible for segmenting the networks and protecting the networks. And we ask them for permission to do something specific. We have a general sense of what we think they will approve. And they're the smart ones that say yay or nay. And then we go about doing what we do. So that's not really all that exciting of an answer, I don't think, but that's the best I can do on that one. William, any others?
Yep, we have, this will be the last question. And if we did not get to your question, please know that all your questions will be sent over to Derek after the webinar ends. But because of time's sake, we are only going to ask this last question. This question is from James. His question is, how do the project controls vendors react to third-party software being added to their installation? Does it promote them completing their operability faster?
Yeah, well, the last part, I think the answer is yes. But I think the gist of the question is, or I take it as is, how do controls contractors react to this? And naturally, the first time they hear that something like OTTO is going to be plugged into their system to automate functional testing, their eyebrows go up or down. Either it could be negative or positive, but they're going to have some questions. Most will. Many already use something like a TOSI box or some sort of VPN gateway for their own purposes. But at the end of the day, automating testing is simply automating, essentially pressing some overrides on the graphics. So it's not a big deal, but this is done in consultation with the controls contractor. So they're still they're a major stakeholder here. So getting their collaboration is important. That being said, it's worth noting there's a major difference between applying connected commissioning in a new construction context versus existing buildings context. In the new construction context, that controls contractor is likely already on the hook for testing those 100 terminal units alongside of you while you're witnessing them. So when you come to the table and you say, we've got this powerful tool that's going to help us find things better, find things quicker. And by the way, we don't need you to follow along with us in testing these 100 terminal units. So, and by the way, when we do test, we're still going to test those 100 terminal units, but you know what? We're going to schedule those at nights or on the weekends. Then your controls contractor becomes a very willing participant. They need to facilitate some networking information and maybe answer a couple questions about how their set points work at the zone level or something. There's a couple nuances that are important to get out of them. But generally speaking, in new construction or a major renovation context, when there's a new control system that got installed, they're on the hook for helping you. And when you find out that you're going to use something to automate a lot of the tedious questions that you're asking, that's good news to them. In an existing building context, it's a different dynamic, and it can be all across the board. But if no one's on the hook for helping you out, you're going to have to figure out some things yourself. And the key to all those answers is to get login credentials to the front end, the graphics, if you will, of the control system, and you can get your questions answered that you need.
Thank you so
much. All right, thank you, William.
Well, Derek, a big thanks to you for such a great presentation and discussion. And thanks again to our sponsor, CX Alloy. Looking to cut energy waste and boost building performance? This 4-hour virtual course is happening on Wednesday, June 11th, 2025, from 1 p.m. to 5 p.m. Eastern. And it's built for facility teams managing corporate, healthcare, higher education, and K-12 campuses. Learn practical tools to improve efficiency, earn 4 AIA-LUs, receive a certificate of completion, and get access to the recording and handouts. Visit energymgmt.org for more information, or you can scan the QR code right there on the screen to register. Once again, thank you all for attending and look forward to seeing you next time. Have a good day.